السلام عليكم، أنا الطالبة نور وميض من مدرسة الموهوبين. اليوم عندي موضوع عن النانوتكنولوجيا and انرجي بإشراف الدكتورة إباء عدنان. Nanotechnology. Nanotechnology is the science that's interested in studying the material to the atomic and molecular scale. Nanotechnology is interested in creating new technologies and means whose dimensions are measured in nanometers, which is 1,000 of a micrometer or 1 part of a million of a millimeter. Nanotechnology is being used in several applications to improve the efficiency or energy generation or develop new methods to generate energy. Usually, nanotechnology deals with measurements between 1 to 100 nanometers, meaning that it deals with atomic clusters ranging from 5 to 1,000 atoms, which are dimensions much smaller than those of bacteria and living cells. So far, this technique does not only care about the biology science, but concerns the properties of materials, and its fields are widely diverse, from semiconductors to fairly modern approaches to the molecular self-assembly. This limitation is offset by the broadening of the nature of the materials used. Nanotechnology deals with any phenomena or structures at the small nano level. Neurosciences and nanotechnology is one of the fields of material sciences, and these sciences contact with physics, mechanical engineering, bioengineering, and chemical engineering form branches and various subspecialties within these sciences, all of which relate to the investigation of the properties of matter at a small level. Neurosciences and nanotechnology is one of the fields of material sciences, and these sciences contact with physics, mechanical engineering, bioengineering, and chemical engineering form branches and various subspecialties within these sciences, all of which relate to the investigation of the properties of matter at a small level. Nanotechnology is being used in several applications to improve the efficiency or energy generation or develop new methods to generate energy. Energy applications of nanotechnology. As the world's energy demand continues to grow, the development of more efficient and sustainable technologies for generating and storing energy is becoming increasingly important. According to Dr. Wade Adams from Rice University, energy will be the most pressing problem facing humanity in the next 50 years, and nanotechnology has potential to solve this issue. Nanotechnology, a relatively new field of science and engineering, has shown promise to have a significant impact on the energy industry. People in the fields of science and engineering have already begun developing ways to utilizing nanotechnology for the development of consumer products. Benefits such as these make the investment of capital in the research and development of nanotechnology a top priority. Benefits already observed from the design of these products are an increased efficiency of lighting and heating, increased electrical storage capacity, and a decrease in the amount of pollution from the use of energy. Benefits such as these make the investment of capital in the research and development of nanotechnology a top priority. Nanomaterials in solar cells. Nanomaterials can contribute to solar cell design in different ways, which play an important role in their performances. Development of nanomaterials-based solar cells could reduce the cost and stability for bulk power generation as well as enhance the power conversion efficiency. Generating steam from sunlight. Researchers have demonstrated that sunlight concentrated of nanoparticles can produce steam with high energy efficiency. The solar steam device is intended to be used in areas of developing countries without electricity for applications such as purifying water or disinfecting dental instruments. Another research group is developing nanoparticles intended to use sunlight to generate steam for use in running power plants. Reducing power loss in electric transmission wires. Researchers at Rice University are developing wires containing carbon nanotubes that would have significantly lower resistance than the wires currently used in the electric transmission grid. Richard Samelli envisioned the use of nanotechnology to radically change the electricity distribution grid. Samelli's concept these upgraded transmission wires, which could transmit electricity thousands of miles with insignificant power losses, with local electricity storage capacity in the form of batteries in each building that could store power for 24 hours. Use nanoparticles full identifiers. Nanomaterials can be used in a variety of ways to reduce energy consumption. Nanoparticles full additives can also be of great use in reducing carbon emissions and increasing the efficiency of composition fuels. Cerium oxide nanoparticles have been shown to be very good at catalyzing the decomposition of unburned hydrocarbons and other small particles emissions due to their high surface area to volume ratio, as well as lowering the pressure within the combustion chamber of engines to increase engine efficiency and curb emissions. Addition of carbon nanoparticles has also successfully increased burning rate and ignition delay in jet fuel, making the production of fuel from raw material more efficient. Nanotechnology can address the shortage of fossil fuel, such as diesel and gasoline, by making the production of fuels from low-grade raw material economical. Nanotechnology can also be used to increase the mileage of engines and make the production of fuels from normal raw material more efficient. Environmental and health impacts of fuel additives. While nanomaterials can increase energy efficiency of fuel in several ways, a drawback of their use lies in the effect of nanoparticles on the environment. With cerium oxide nanoparticles additives in fuel, trace amounts of these toxic particles can be emitted within the exhaust. Cerium oxide additives in diesel fuel have been shown to cause lung inflammation and increase bronchial alveolar lavage fluid. This is concerning, especially in areas with high road traffic where these particles are likely to accumulate and cause adverse health effects. Naturally, occurring nanoparticles created by the incomplete combustion of diesel fuels are also large contributors to toxicity of diesel forms. More research needs to be conducted to determine whether the addition of artificial nanoparticles to fuels decreases the net amount of toxic particles emissions due to combustion. Improving the performance of batteries. Companies are currently developing batteries using nanomaterials. One such battery will be as good as a new after sitting on the shelf for decades. Another battery can be recharged significantly faster than conventional batteries. The Li-ion battery is currently one of the most popular electrochemical energy storage systems and has been widely used in areas from portable electronics to electric vehicles. However, the gravimetric energy density of Li-ion batteries is limited and less than that of fossil fuels. The lithium-silver battery, which has a much higher energy density and than the Li-ion battery, has been attracting worldwide attention in recent years. A group of researchers from the National Natural Science Foundation of China and the Ningbo Science and Technology Innovation team have developed a nanostructure-based lithium-silver battery consisting of graphene, silver, carbon, nanocomposition multi-layer structures. Nanomodification of silver can increase the electrical conductivity of the battery and improve electrical transformation in the silver cathode. The graphene silver carbon composition shows promising characteristics as a high performance cathode material for lithium silver batteries. Nanomaterials and energy. An important subfield of nanotechnology related to energy is nanofabrication, the process of designing and creating devices on the nanoscale. The ability of create devices smaller than 100 nanometers opens many doors for the development of new ways to capture, store, and transfer energy. Improvements in the precision of nanofabrication technologies are critical to solving many energy related problems that the world is currently facing. Graphene based materials. There is enormous interest in the use of graphene based materials for energy storage. The research on the use of graphene for energy storage began very recently, but the growth rate of relative research is rapid. Graphene recently emerged as a promising material for energy storage because of several properties, such as low weight, chemical inertance, and low price. Graphene is an allotrope of carbon that exists in a two-dimensional sheet of carbon atoms organized in a hexagonal lattice. A family of graphene-related materials called graphenes by the research community consists of structural or chemical derivatives of graphene. Graphene has great potential in the modification of a silver cathode for high-performance lithium-silver batteries, which has been broadly investigated in recent years. Structures of graphene-based materials. Silicon-based nanosemiconductors. Silicon-based nanosemiconductors have the most useful application in solar energy, and it also has been extensively studied at many places, such as Kyoto University. They utilize silicon nanoparticles in order to absorb a greater range of wavelengths from the electromagnetic spectrum. This can be done by putting many identical and equally spaced silicon rods on the surface. Also, the height and length of spacing have to be optimized for reaching the best results. This arrangement of silicon particles allows solar energy to be reabsorbed by many different particles, exhausting electron and resulting in much of the energy being converted to heat. Then the heat can be converted to electricity. Researchers from Kyoto University have shown that these nanoscale semiconductors can increase efficiency by at least 40% compared to the regular solar cells. Silicon-based nanosemiconductors. Nanocellulose-based materials. Cellulose is the most abundant natural polymer on Earth. Currently, nanocellulose-based mesoporous structures, flexible, thin films, fibers, and networks are developed and used in photovoltaic devices, energy storage systems, mechanical energy harvesters, and catalyst components. Inclusion of nanocellulose in those energy-related devices largely raises the portion of eco-friendly materials and is very promising in addressing the relevant environmental concerns. Furthermore, cellulose manifests itself in the low cost and large scale promises. Nanocellulose based materials for water purification. Economic benefits. The relatively recent shift towards using nanotechnology with respect to the capture, transfer, and storage of energy has and will continue to have many positive economic impacts on society. The control of materials that nanotechnology offers to scientists and engineers of consumer products is one of the most important aspects of nanotechnology and allows for efficiency improvements of a variety of products. More efficient capture and storage of energy by use of nanotechnology may lead to decreased energy costs in the future as preparation costs of nanomaterials becomes less expensive with more development. A major issue with solar energy generation is the generation of waste heat as a byproduct of combustion. A common example of this is an internal combustion engine. The internal combustion engine loses about 64% of the energy from gasoline as heat and as an improvement of this alone could have a significant economic impact. However, improving the internal combustion engine in this respect has proven to be extremely difficult without sacrificing performance. Improving the efficiency of fuel cells through the use of nanotechnology appears to be more plausible by using molecularly tailored catalysts, polymer membranes, and improved fuel storage. In order for a fuel cell to operate, particularly of the hydrogen variant, a noble metal catalyst, usually platinum, which is very expensive, is needed to separate the electrons from the protons of the hydrogen atoms. However, catalysts of this type are extremely sensitive to carbon monoxide reactions. In order to combat this, alcohols or hydrocarbons compounds are used to lower the carbon monoxide concentration in the system. Using nanotechnology, catalysts can be designed through nanofabrication that limit incomplete combustion and thus decrease the amount of carbon monoxide, improving the efficiency of the process. Thank you for watching.